The first question is cos 20, cos 40, cos 60, cos 80. You have to prove it to be equal to 1 by 16. So cos 60 is 1 by 2. Cos 20 into cos 40 can be written as cos 60 minus 20. And cos 80 can be written as cos 60 plus 20. And this is like cos A plus B into cos A minus B. But there are two different formulas. One is cos square A minus sin square B, or cos square B minus sin square A. I'm going to use this formula. So it's cos 20 into cos square 20 minus sin square 60. So 1 by 2 into cos 20 into cos square 20 minus 3 by 4. So on taking LCM, I'll get 4 cos square 20 minus 3. This 4 will become an LCM and can come out as 8. Taking the cos 20 inside, we get 4 cos cube 20 minus 3 cos 20, which itself is cos 60, and a cos 60 is 1 by 2. The proof that is 1 by 16. We got the answer. Second question. Prove that secant 8a minus 1 by secant 4a minus 1 is equal to tan 8a by tan 2a. Let's write this as sin and cos, make it easier. 1 by cos 8a minus 1 by 1 by cos 4a minus 1. Take LCM. 1 minus cos 8a by cos 8a by 1 minus cos 4a by cos 4a. And 1 minus cos x is 2 sin square x by 2 by a cos 8a by 1 minus cos x is again 2 sin square 2a by cos 4a. Take it up. 2 sin square 4a into cos 4a by a 2 sin square 2a into cos 8a, which is there in the denominator. Now I want tan 8a. I have, let's cancel this sin square 4a and write it as sin 4a into sin 4a. So that this 2 sin 4a cos 4a is sin 8a. By this cos 8a has given us a tan 2a, which is what you need. You can write this sin 4a as 2 sin 2a cos 2a by, you also have a 2 sin square 2a in the denominator. The 2 and 2 get cancelled. Sin 2a and the power get cancelled. This itself is cot 2a. Therefore, it is tan 8a into cot 2a, which is tan by tan 2a, and you got your answer. So let's go to next question, which is the third question. Okay, they've given cot alpha to be 1 by 2, where alpha is an element of pi by 2 to 3 pi by 2, which shows that alpha is lying in the third quadrant. And they're saying secant beta is equal to minus pi by 3, where beta lies between pi by 2 and pi, which means it's in the second quadrant. Okay, so they're asking you to find tan alpha plus beta, which is tan alpha plus tan beta by 1 minus tan alpha tan beta. A cot alpha's reciprocal is tan alpha. You don't know tan beta, but look at this. You can use secant square beta minus tan square beta is equal to 1, and using identity you can find tan beta. Alternatively, I'll teach you an easier way. A secant beta is hypotenuse by adjacent. So this will be 5. 3, 4 and 5 is a triplet, sorry. You know 9 plus 16 will be 25. So this forms a triplet. So therefore you can write tan beta to be 4 by 3. So, but you know beta is in which quadrant? Second quadrant. Obviously it's got to be minus 4 by 3. Correct? By 1 minus 2 into minus 4 by 3. So it is 2 by 3 by 1 plus 8 by 3. And so you get 2 by 3 by 11 by 3. 3 get cancelled. As 2 by 11 is your answer. Okay. So let's go to next sum. So you should understand what are the triplets. 3, 4 and 5 is a triplet. You know 1, 2 root 3 is a triplet, which we already know of. You know this angle is 60 degree and this angle is 45 degree. That's a triplet. We also know that a 5, a 12 and a 13 can be a triplet. Like this we can arrive at various triplets. 1 1 root 2 is a triplet. Okay, so remember this triplets so that you can do the sum. Let's go to next sum. Prove that a cos alpha plus cos beta plus cos gamma plus cos of alpha plus beta plus gamma. What is this? This cos C plus cos D, which is 2 cos and cos, C plus D by 2, C minus D by 2, plus 2 cos and cos, excuse me, sorry, 2 cos and cos. Okay, so C plus D by 2 is a gamma plus alpha plus beta plus gamma by 2, and a cos gamma minus alpha minus beta minus gamma by 2. Gamma get cancelled. This is 2 cos alpha plus beta by 2 into cos alpha minus beta by 2 plus 2 cos alpha plus beta plus 2 gamma by 2. And this is cos of minus of alpha plus beta by 2, and cos of minus theta is anyway cos theta. We can ignore the negative sign, and you can take out a 2 cos alpha plus beta by 2 out. So you'll be left with cos alpha minus beta by 2 plus cos of alpha plus beta plus 2 gamma by 2 is what you're left with. And then you have to again do cos C plus cos D in here. So 2 cos alpha plus beta by 2 outside, 2 cos C plus cos D is 2 cos C plus D by 2 is basically alpha minus beta by 2 plus alpha plus beta plus 2 gamma by 2, and alpha minus beta by 2 minus alpha plus beta plus 2 gamma by 2. So on solving this, 2 cos alpha plus beta by 2 into 2 into cos of, take 2 as LCM, 2 2s are 4 will become in the denominator. Beta and beta is getting cancelled. You get 2 alpha plus 2 gamma, and here if you take LCM again as 4, alpha and alpha is getting cancelled. Get minus 2 beta minus 2 beta minus 2 gamma, and even cos of minus theta is cos theta. Minus can go away. The 2 and 4 get cancelled. The 2 can come forward. Cos of alpha plus beta by 2 into cos of alpha plus gamma by 2 into cos of beta plus gamma by 2, and I think that's exactly what you need to prove in the right hand side. Okay, if you see the PDF, you'll understand that they're asking for the proof only. So let's go to fifth question. The fifth question is this: if sine alpha plus sine beta is equal to A, cos alpha plus cos beta is equal to B, prove that cos of alpha plus beta is B square minus A square by B square plus A square. I would do the sum using right hand side. What is B square? Which is cos alpha plus cos beta the whole square minus sin alpha plus sin beta the whole square by cos alpha plus cos beta the whole square plus sin alpha plus sin beta the whole square. Expand it. Let's not expand like you do in 10th standard. Let's do 2 cos alpha plus beta by 2 alpha minus beta by 2, and this is a square whole square, so you can make it like this. Minus sin alpha plus sin beta is like sin C plus sin D, which is 2 sin and cos alpha plus beta by 2 into alpha minus beta by 2, and the whole square is there, so we can make it 4 sin square cos square. Okay, and by this is cos C plus cos D, which is repetition of this cos square alpha plus beta by 2 cos square alpha minus beta by 2 plus a 4 sin square alpha plus beta by 2 into cos square alpha minus beta by 2. Now see what's common, and just identify what's common. 4 cos square alpha minus beta by 2 is common. A 4 cos square alpha minus beta by 2. By in the denominator also 4 cos square alpha minus beta by 2 is common, is getting cancelled. So what are you left with? A cos square alpha plus beta by 2 minus Sin square alpha plus beta by 2 by, in the denominator, cos square alpha plus beta by 2 plus a sin square alpha plus beta by 2. You're left with this. And then this actually what you have in common here, when you take it common, if you see in the numerator, you have 4 cos square alpha minus beta by 2, and denominator you have 4 cos square alpha minus beta by 2. You have cos square alpha plus beta by 2 minus sin square alpha plus beta by 2 by cos square alpha plus beta by 2 plus sin square alpha plus beta by 2. So this itself is 1. This itself is a cos 2 theta, a cos square theta minus sin square theta, which is cos of alpha plus beta. And apart from that, you also have a, this is cancelled, right? The denominator, this is totally cancelled. So you got which is cos of alpha plus beta, which is cos square theta by 2 minus sin square theta by 2, which is what you want. Okay, so that's correct. So take it out, common. 4 cos square alpha minus beta by 2 was common. They both got cancelled. So that's about the sum. So let's go to next sum. Show that it's root of 2 plus root of 2 plus root of 2 cos 4 theta. Just solve this root alone. Take 1 plus cos 4 theta, clapping formula. 1 plus cos theta is 2 cos square theta by 2. So 2 cos square 2 theta. And you still have a root of 2 plus, and the square root of this is 2 plus 2 cos 2 theta. And again take a 2 out, you get 1 plus cos 2 theta, and a clapping formula again 1 plus cos theta is 2 cos square theta by 2. So it will become 4 cos square theta, which is 2 cos theta, and that's an important question. Okay, they can prolong it with the many roots there. And the 7th question that I did in the class is find the angle between the hour hand and the minute hand for time 7:20. 20 is the minute hand, and the small hand it will not be exactly at 7, it will be slightly away from 7, and they want the angle between the minute hand and the hour hand. You should know that a minute hand moves through a degree of 6 degree, because 360 degree by 60 minutes is 6. So for every tick, for every single tick movement or 1 minute, it moves 6 degree. So for 20, it's 20 into 6, 20 minutes is 120 degree. Okay, and similarly for the hour hand is in 7. Hour hand is in 7, and okay, so we finished the minute hand, or we can even say for every here it's 30 minutes, because it's got 5 ticks there, 6 5s are 30. So 30 degree is the angle here. For every 5 minutes there are 4 sets, right? 5 4s are 20. So 30 into 4 is also 120. Whichever way you want to think, you can think. Okay, that's about that. And let's look at the hour hand now. The angle that the hour hand totally has made is till 7. As I said, till 7, I will multiply it with 30 and I'll get 210, because I'm considering this to be 30. So then for 7 into 30, 210 degree. But it's not exactly at 7. There is an additional angle through which it's moved, as you can see from here. And you should know for every minute, the hour hand moves through an angle half a degree. So half a degree into 20 makes it additional 10. So 220 degree is the hour hand's angle from 12 o'clock from here. So 220 minus 120, and so then therefore the angle is 100 degrees, the angle between the hour hand and the minute hand in this sum. So the 8th question is a tan 3x into tan 2x into tan x is equal to tan 3x minus tan 2x minus tan x. In this sum, how do you start the sum? You should start the sum using tan 3x out of the blue, because there's no such formula here, right? So it's tan 2x plus tan x by 1 minus tan 2x into tan x, and rewrite this as tan 3x back again and cross multiply. You get tan 3x minus tan 3x, tan 2x, tan x is equal to tan 2x plus tan x. Group according to what you want. The tan 3x minus tan 2x minus tan x, and this can come to the other side, and you proved what you want. It's such a sum that has got to be remembered. It's ninth question. It's about show that tan 69 plus tan 66 by 1 minus tan 69 tan 66. It's like tan A plus tan B by 1 minus tan A tan B. I have to prove it to be equal to minus 1. So it's tan 69 plus 66, which is tan of say 135, which can be written as tan 180 minus 45. You know, it's the second quadrant where sign only can be positive, even integral. So minus tan 45, therefore the answer is minus 1. Let's go to next question. Cos of minus 1710 degree. You all know cos of minus theta is cos theta. That's the first step. And then you should know the revolution. This is 360 degree. For one complete revolution, 720, 1080, 1440, 1800 for fifth revolution, and so on. And so then you should identify this to be closest to which one. If you see, it's 1800 minus 90. So you can write it as cos of 1800 minus 90. The 1800 needle is here. Minus 90 makes it this, and the y-axis cos angle is always 0. Correct, and so then the answer will be 0 because cos will always be 0 on y-axis. Okay, you know this is even integral, and therefore it will result in which quadrant? This is no quadrant, it's not quadrants on the axis, and so the value is just 0. So these are the sums, first set of sums, and I'll put the next set of sums in the next video.